Hi everyone, welcome to this presentation on inferential statistics, which is a branch of statistics that aims to draw conclusions about population based on sample data taken from the population itself. The key objective of inferential statistics are, for example, estimation. You might want to do estimation of population parameters using sample statistics, for example, using sample mean to estimate the population mean. Hypothesis testing would be another area where assessing evidence provided by data in favor or against a specific hypothesis might be of interest to data scientists. Prediction and model building are a couple of other areas where we use inferential statistics. It's actually a very useful tool for data scientists working in the field of medicine, economics, psychology, and social sciences. So without further delay, let's get started. Some of the prerequisites that we need to know, some elementary knowledge about statistics and probability. For example, probability density function, the cumulative density function, and so on and so forth. Python programming would be highly useful, and some elementary ideas about data science as such and machine learning. The topics that I'll be covering here, I'll provide the overview on inferential statistics to start with, and then I'll cover some popular inferential techniques like t-test, ANOVA, chi-square, runs test, and z-test. So what is inferential statistics? It's about making inferences or prediction about a population from sample data. So let's define inferential statistics. It's a branch of statistics that involves making predictions or inferences about uh, some population parameter using sample data. And it allows the business leaders to make decisions or draw conclusions based on sample data about a population parameter. So types of inferential statistics that are commonly used. So this is one type, hypothesis testing. And we will be covering hypothesis testing in detail here. For example, t-test, f-test, z-test, ANOVA, run test, sign test, and so on and so forth. Another type of inferential statistic would be a regression analysis, starting with linear regression, basic regressions, and going up to polynomial and some of the advanced regression techniques like logistic regression, ordinal regression, nominal. So these two are popularly used as part of your inferential statistics. In this video series, we will be talking about hypothesis testing primarily. So what is hypothesis? Is about, you know, some notion or a belief. And hypothesis testing is a technique whereby we make inferences about a larger population based on the sample of data. So essentially involves formulating or setting up the hypothesis about the population parameter, for example, mean, median, and variances. And we will collect the data to do this exercise, and then we apply various statistical techniques suitable for the project or the problem statement and the data type that we're dealing with. So hypothesis, the couple of hypotheses here, let's say examples. The two hypotheses that we set are null hypothesis and the alternate hypothesis. In the null hypothesis is, which is commonly believed or a notion and statement saying that there is no significant difference. That would be null hypothesis. For example, if we were to assess if the height of people in a certain city is about, let's say, 6 feet, then that if that is the common belief, that the null hypothesis would be the mean height is going to be 6 feet. And the alternate hypothesis would be the counter, which is the researcher is trying to validate. And that would be the mean is not equal to 6 feet. Some more examples here. Let's say the market research, and you have a sample of 100 customers who participated in the some kind of study. And if we were to divide the customers in the age group, let's say young and middle-aged, and the older population. So there are three groups of customers, and we have taken data for those customers and their preferences for, let's say, television screen sizes. And you would like to establish some sort of relation between the age group and the screen size. So that would be one example of inferential technique or hypothesis testing. So this is the kind of data that we obtain, the age group and the screen size preferences, and then applying proper statistical tests or inferential technique, we can say if these two variables are impacting or not. So let's look at another example. Let's say we are talking about a leader and the leader has a sales team and let's say a couple of sales team within the organization, and you would like to check if the productivity scores of the team members in the sales team A and B, they have any sort of relation, or these are the performance scores, or let's say the number of units sold, and you would like to see if the teams are selling equal amount of or equal quantities of the item. So that would be another example of hypothesis testing. Let's talk about one more, and this is the customer satisfaction scores. And this is another set of customer satisfaction scores by team. Again, training effectiveness. So you have a team, and before the training, you collected these scores, and after the team has gone through the training and you have collected the customer satisfaction score, and you would like to see if there is any improvement in this score or not. So that would be a very useful, business decision tool. And this is another example of hypothesis testing. Let's talk about one more medical treatment. Let's say we have a new drug and the new drug is introduced and you would like to assess if the new drug has effect on the patients. So the null hypothesis would be something saying, oh, new drug has no impact. So that's how you're going to start. And the counter hypothesis would be the new drug has effect, either bad or good. So you would like to step validate that. Similarly, educational intervention, teaching method being introduced, and before the method is introduced, you collect the score, and after the method is introduced, you collect the scores again, and then you compare. And after that, you make an interpretation whether the teaching method was really effective or not. Employee satisfaction, again, similar. So let's say the employees have been given some incentive, some change in the work schedule, and then you measure the employee satisfaction before the intervention and after the intervention, and then you compare. So that would be another example. Let's talk about another example here. This is the data set from a very popular UCI source, and this is about California region, and these are the houses or house prices. So these some of the columns here that median income in this region and similarly the house age in that particular region, and all these columns define the price of the house, that particular house. And here we might want to check if let's say the house age has anything to do with the price of the house, or median income of the people in that region has anything to do with the price of the house. Now, these are examples of hypothesis testing again. So, if you look at it, they're not just establishing the or validating the relations between the column and the desired dependent column. This is also a technique which helps determine if the columns are really useful in your model or not. So you can reject or drop those columns if they are not influencing the final dependent column. So hypothesis testing is not about just establishing the notion or countering the notion, but this is also very useful for feature selection. So let's talk about one more here. So in this regard only, like California data set, you might want to check if the age of the house and the house price they have any sort of influence between themselves. So ideally, you're going to set the null hypothesis saying there is no relation between these two columns. And then after that, you collect the samples for age of houses and the house value and conduct a proper suitable inferential technique and then conclude. So it really helps machine learning in terms of finding out if certain columns are really useful or not useful. Okay, so likewise, we can also talk about another example here, the credit scoring in finance. You would like to establish um, the relation within the data set, let's say collecting the data on the loans and then apply the old and the new credit scoring model to see if the new model is better than the old model or not. So the process of hypothesis testing essentially is quite simple. You will be collecting the data. So essentially, you start with setting the objective first, whether the relations exist between the column. And then you choose a proper statistical technique and either t-test, ANOVA, or mutual information or chi-square. There are a whole lot of inferential techniques, and I'll be covering at least some of them in the video series. So one little piece of information, there are limitations with the hypothesis testing. As such, I mean, it doesn't consider interaction or the interplay between the variables. The relationship is pretty much one column versus the other column. So here we're not looking at multiple columns uh, in the play. So the mitigation would be we have to use different technique, which allows for multivariate feature selection. In this video series, we'll look at univariate analysis, basically one column versus another column or another value. So these are limitations here. One more limitation with the hypothesis testing or inferential technique that I'm talking about in this video series is independence of data among the columns. So we need to make sure the data has no dependencies among themselves. So that means it should be fairly independent of each other. If you have dependence or relations within the data, let's say row number one has a relation with row number two or three, we might want to choose, different kind of machine learning model. For example, tree-based models like random forests or decision trees or boosting methods and so on and so forth. So a couple of things of significance here. In order to conduct the hypothesis testing, three important things that we need. One is the test statistic. So that meaning you have a model and you pass your sample data. And with the sample data, the model or the inferential technique is going to get you some output, and that output is your t statistic. Essentially, this is a number that you get as an output. Now, that number has to be understood or compared with the critical value to conclude. So, we're going to talk about these three essential ingredients of hypothesis testing: the test statistic, and the p-value, which is the probability value, and then the critical value. So test statistic needs to be compared against the critical value for the final conclusion. So let's take an example to understand how these test statistic and p-value and the critical values are related. Let's say the exercise is you want to test if the average height of certain population is 65 inches or not, or if it is different than 65 inches. So the null hypothesis would be the height is indeed 65 inches. That's how we're going to start with that exercise. And the alternate hypothesis would be the height is not 65, something lesser than 65 or something maybe more than 65. So we have set the null hypothesis here. So typically the null hypothesis, some of the principles that we follow in setting the null hypothesis is saying there is no change, no effect, things are pretty good, and things are as is or as it is known. So those are principles used in setting the null hypothesis. For example, mean height is 65 inches because that is given or that is understood or that is believed by the people. So we set the null hypothesis as 65 inches to start with. Alternate hypothesis would be just the opposite. So either you can set it is not equal to 65, that means it could be lesser or more, or it can be more than 65, or it can be less than 65. So there are these three possibilities or three variations of inferential techniques are commonly used. So simply stating the null hypothesis means nothing unusual going on. Life is good, data is good, so no need to really worry about it. And as a researcher, we are going to validate that belief. So the belief is if the new medicine is really helping the patients, or the height of the population is indeed not 65 or lesser than 65 or more than 65 inches. So let's see some examples here. Let's say the e-commerce conversion rate, the recent website change you did, the null hypothesis would be, oh, the change doesn't really help much. That's how you're going to set the null hypothesis. Click-through rate again. So let's say you made some changes, or you introduced some loyalty program, and because of that you are anticipating more or better click-through rate. So the null hypothesis would be, oh, click-through rate doesn't change. That's same as it was before, and then you would like to validate that. So likewise, the customer churn analysis again. Let's say you introduce some new program, new loyalty program, so null hypothesis would be the churn rate is the same as before, and then you would like to validate that using some sample data. Similarly, product recommendations also. I mean, you introduce or you recommended some product, so the null hypothesis would be it doesn't lead to any better customer satisfaction or something like that, and then you would validate that. So that's the part one of the exercise, and the second is setting the significance level. Now, this significance level is very, very important aspect of hypothesis testing or inferential technique. So this is a kind of a threshold that you set. Beyond the threshold, you are then in a position to reject the null hypothesis. So normally we take about 5% as the threshold level, and if you are within 5% region, for example, here, then you might want to reject the null hypothesis. And I'm going to talk about how this is actually done. And significance level is like how much of error your model is, capable, or you are ready to absorb, or how much of error your business is ready to absorb. 1%, half a percent, 2%, 3%, 10%. So this is all depend. This all depends on the criticality of the business and how much tolerance you have to to absorb the error. So that defines your significance level. But typically for finance data, non-critical data, 5% is the ballpark threshold level or significance level that we set. Now after that, we carry out the test. So that simply means you will collect some sample, let's say 100 people, and then you measure the heights, and that is your sample. And then after that, we choose the statistical function, let's say t-test. And to the t-test, you provide the sample data, and the t-test is going to give you the test statistic. That's a number, and that number we will use to make the conclusion. We're going to talk about p-value as well. So the p-value can be derived from test statistic. We will look at how it is actually derived from the test statistic. Both of these are useful numbers to make conclusion finally. So when you conclude, essentially, you look for p-value, probability value is within the 5% level or not. If it is within the 5% level, then you can counter the null hypothesis or you can reject the null hypothesis. And the same thing you can do with the test statistic as well. So if the test statistic is more than the critical value, then you can reject the null hypothesis. So we're going to see the examples of how p-value and critical value and test statistic are related and how they are actually used in the subsequent examples. Now, type 1 error is the case where you're making error in prediction. For example, when the null hypothesis is true, that means the mean of the or the height, mean height is indeed 65 inches, but your sample said it is not 65. So that's the type 1 error. And it's also called false positive error. Similarly, type 2 error is just the opposite of that, and which will mean that when the null hypothesis is indeed false, but you have accepted it or you have not rejected it. So you fail to reject it. So these two errors are the trade-off that we make in the process of hypothesis testing or making conclusions or forecasting it. So that's pretty much as the background behind the inferential technique. In the next topic or next video, we will see how t-test is actually set up and the variations of the t-test. See you in the next video.